Okay, the author goes through on two-dimensional figures. First, the author defines a polygon. A polygon is a closed plane figure within sides. A polygon is a closed plane figure within sides. The sides that have a common endpoint are non-collinear. The sides that have a common endpoint are non-collinear. And each side intersects exactly two other sides, but only at their endpoints. So a polygon is a closed plane figure within sides. The sides that have a common endpoint are non-collinear. That'd be like looking at, here's one side, here's another side. They are not on the same line. Okay? And each side intersects exactly two other sides. So if I look at this side, it's intersecting one side here and one side here. And they intersect at their endpoints. Now, examples of polygons. You've worked with polygons before. When you talk about a hexagon, a rectangle, a triangle, a square, a pentagon. Okay? Those are all polygons. Okay, this one is still a polygon. It has 1, 2, 3, 4, 5, 6, 7 sides. That would be a heptagon. H-E-P-T, heptagon. Okay? If it has any curves in it, it's not a polygon. Okay? So those are examples of polygons. Okay, here's examples that are not polygons. If it's not a closed figure, okay, like this one, if they don't close it here, then it's not a polygon. So one that's not closed. Another example, this one kind of looks like the old Pac-Man. If it's got a curve on it, if it's not made up of line segments, then it's not a polygon. On this one is not a polygon. Okay, the sides do not intersect in exactly two places at the endpoints. Okay, these two lines intersect not just at the endpoints, they also intersect right here. That is not a polygon. Okay. Okay, then the author defines a concave polygon. We just did convex polygons in pre-calc yesterday. Today we talk about concave polygons. If the lines containing each side of the polygon, are drawn, and if the line contains any point on the interior of the polygon, then it's considered concave. Okay, if the lines containing each side of the polygon are drawn, and if the line contains any point on the interior of the polygon, then it's considered concave. Okay, an example. Okay, I started out with that shape. Okay, if you draw a line containing, I'm going to draw a line containing this line. Okay? If it contains any points here in the interior, then it's considered concave. Okay? Same thing here, I drew that shape first. If I can draw a line containing that, and if it contains any points in the interior, it's considered concave. Okay? Same thing here, like I could draw this from here to here. That's concave. Those are all concave examples. Okay, if it's not concave, and any of you down the road, some of you will go into physics, and they talk about concave and convex mirrors. A lot of times when you're shopping, you'll see they have mirrors up in the corners of the shop, okay, and that's so they can see more, okay. Okay, convex polygons, it's when the lines are drawn containing each side. The lines do not contain any point in the interior. And those are called convex polygons. If I drew a line from any of those, I'm not going to end up with anything in the interior. No matter where I draw that, it's just going to go around the outside. That's an example of a convex polygon. What about a triangle? Just a regular triangle. You'd never get that. Would be a convex polygon. There's another convex polygon. Okay. There's a couple more. Okay. A pentagon, a hexagon, a rectangle, those are all convex. You can extend those lines and you're never going to get anything in the interior. Nothing here in the interior. Okay? Okay, now, a key word in geometry, and you don't want to let your eyes skip over it in the word problems or in the directions. What does it mean when they say a regular polygon? The key word is regular. Okay, a regular polygon. It's a convex polygon in which all the sides and all the angles are congruent. All the sides and all the angles are congruent. Example, like a square. And if they were doing a square as a regular polygon, in the book, you got to look. If it was a square, the author's going to do this, and it's not going to be very bright or very big, so you just have to look. That symbol tells you that all those sides are the same length. Okay? And then the angles, like on this one on a square, they would show you that they're all right angles. Okay? It might be a hexagon. Okay, if they did this as, say up here, if this was a hexagon, they would use a little red line here. It would be a black drawing, and they'd show you that all those are the same length. And then they'd have to show you that these angles are all the same size, okay, for it to be regular. The main thing is when you're reading the problems, they're giving you a hint when they say the word regular. That's telling you that all the sides are the same length, all the angles are the same size. So don't skip over that word. Don't let your eyes skip over. It's a reading problem too. Okay, a polygon is named by the letters of its vertices in consecutive order. And normally they're going to start alphabetical. So like we would say this is a 1, 2, 3, 4, 5. It's a pentagon. This one does not look like it's regular. Okay, and it doesn't have any markings to show it's regular. But it would still be a pentagon. It's still 5 sides. And it would be a pentagon A, B, C, D, E. Could I start at a different letter? Yes. But if I start at B, then it's got to go B, C, D, E, A. Most of the time they're going to do it alphabetical. But they have to be in order, consecutive order. Like if I said it was pentagon B, D, C, no, that's not right. It's got to be in order all the way around. Okay. Okay, and then if they talk about an n-gon, that's a polygon with n sides. Most of them you know, like a square, a rectangle, 5 sides pentagon, 6 sides hexagon, 7 sides heptagon. I think you have a table in your iPad that lists those. 8 sides, what do you call it? 8 sides? Octagon, that's like a stop sign. 9 sides, nonagon. 10 sides, decagon. Yeah. 12, dodeca. Yeah. They have them in your book. Okay. The perimeter of a polygon, you add all the sides. Perimeter means you add all the way around. Perimeter of a polygon is the sum, so you add the lengths all the way around. Perimeter of a triangle is usually, they label the sides A, B, C. You just add them up. Perimeter, use P for perimeter. For a square, each side is S. So the perimeter of a square, you could go S plus S plus S plus S, but it's easier if you just say 4 times S. Probably the most important one there is the perimeter of a rectangle. Perimeter of a rectangle, if L is the length and W is the width, perimeter equals 2L plus 2W. Okay. And if they ask you to find those, you write the formula down, sub in, and then just simplify it. Still order of operations. Okay? Order of operations. And that's it. Okay? That's it.